So the last thing we have to do is implement the main client class. What really helped me was a video on YouTube from Mr. Dominic123 who explained this very well and who designed some elegant methods that I adopted for my class too. So the simple application is extended in the main client class, and there are some interfaces that are implemented. So action listener in order to react to user input as keyboard or mouse pressings, and client state listener and message listener of type client in order to send and receive messages or to do something when the client connects to the server or disconnects from it. There's a lot of information that is stored inside our main client object, mainly concerning the position and rotation of the camera or the player. But there is also a reference to the client that we're gonna construct and create in the following. And there's a player's node. Inside the player's node, all other clients are rendered as spatials. So if we want to render the position and rotation of the other clients, we have to use spatials, and they are all inside this node. Of course, there's server IP and server port. Change this if you changed it in main server. And now we have to take a closer look at these two hash maps. These two hash maps are there for storing the information that the server sends every 50 milliseconds to us, and that contains the client data. And the other hash map is there in order to render the spheres that represent the other clients in our scene. So let's take a look at this image. So a hash map of players is simply a list containing the ID of a player and its position and rotation. So in this case, 4 players with 4 IDs. The spatials is exactly a copy of it, but we cannot render position or rotation or client data, but we have to render a spatial. And in this case, the ID 1 is a sphere that has been manipulated with these data, so with the position and rotation of player 1 and of player 2, player 3 and player 4 and so on. Okay, so let's have a closer look. When a main client is initialized, we have to tell what is the server IP and save it here inside. And then we have some methods in order to init the scene. So there's just a simple box that is the ground floor that we can walk on. So it is attached to the bullet app state. It is attached to the root node. We set a blue background color. You can extend this with skyboxes and so on. This is the method in order to get a sphere. So when we generate a sphere with a given ID, we get back a spatial and then can put it into the player's node. So if you want a real enemy, then you should not use generate sphere, but generate enemy or so, something like this. In the simple init app, this is the first method that is being run. We create a new players and a new spatials hash map and a new players node to put the spatials into. We attach it to the root node and then we connect to the server. Of course, we also have to register all those message classes that we use to communicate with the server, add the message and client state listener, and then start the client finally. Okay, then as usual in JMonkeyEngine, we initialize the bullet app state, attach it to the state manager, and set up our keys and set up the scene as I showed before. Okay, set up keys, let's have a look. I didn't change anything from the basic example that comes with JMonkeyEngine. So it's just for walking and jumping around. And then we design a player. A player is a new character control with certain jump and fall speed, and we attach it to the bullet app state, and we set the player to a random location on our plane. So the X and Z component is just a random float so that the player is set on the floor in a random place. I didn't change anything in onAction. It's just for walking and jumping around. And I didn't change anything in simple update because we cannot change the scene in simple update because we receive our client positions and rotations on a separate thread, and from there we have to tell the scene to be updated, but we cannot do this in simple update. I will show you how you can achieve this with another concept. So it is basically the same as in the simple application. Okay, we do nothing when the client is connected, we do nothing when the client is disconnected, but we do a lot when the client receives a message. Let's first look at the destroy method. Only closes the client and ends it cleanly. So if we get a message, the message could be an instance of a client list message with all client positions and rotations, or the other possibility, it could be an instance of a close message. Okay, so let's have a look. If it is a client list message, we first cast the message because it's from the of the type message. We cast it to a client list message, and then we can get the list with clm.getClientList. This list is a hash map containing the ID and the client data, and we put it into the players. So in this case, we put everything here inside this hash map. And the good thing about put all is that it updates everything. So it does not append a new 1, 2, 3, and 4 to the list, but it updates the values here for the given IDs. And that is very elegant. That's very great. So we do not have to do this on our own. Okay, now we have an updated hash map players, and now we can loop through it. We can loop through it for ID 1, 2, 3, 4, and so on. And for every player, we do the following. We get his player ID. We do get this by a get key. And we get his client data. We do get this by get value. So get key gets this, get value gets this. Okay, if we have this, we can then store in temp the position and the rotation. From the temp client data, we can just fetch these two information and store them in these two variables. Okay, so now we do this updates only if we are not in the list. So if we loop through this list, one of these positions is our position. Maybe we are in position 3, okay, but we don't want to update ourselves. We only want to update the other ones. So, okay, if the player ID is not our ID, then we can do something with the data. Okay, first we must see maybe a new player is in the list, then it is in the list automatically in the players hash map, but it is not in the spatials hash map. So we have to copy the new one from here to here. Okay, let's do this. If the spatials does not contain this player entry ID, then we put this player into the spatial. Okay, we put the ID of the player inside the spatials hash map and a new spatial, and that is just a new sphere, and the sphere gets the player entry ID. You need not do this, I did this in this case. Okay, so the new player is added to the spatials, and then something very magic. We have to put the new player into our scene, and you can't do this from here. You only can tell JMonkeyEngine the next time you execute the update loop, please change something in the root node. And you can see from here, this is the enqueue template. It's exactly this piece of code that you can use to achieve such things. Okay, what do? We attach a new child to the player's node, and that's exactly the sphere with the ID from the loop here, and that is in spatials. Okay, and the next time, so this new spatial is rendered too. Okay, now we have to update all other spatials in the scene, of course. Yeah? Also for the given ID that we are on, because we are looping through every players for this specific ID, we look it up in the spatials hash map, and we set the local translation to the player entry vector. It's the updated position of this client. This client is the same as here in the spatial. We get it out from the spatials hash map, and then we update the position of the player. I just added a little bit to make it appear above the floor and not in the floor, but that doesn't matter here. Okay, we also have to update the rotation. This is done by this quaternion because we extracted from the client data of this specific client the player entry rod, and now we set the local rotation to this value. Okay, so all other spatials in the scene are updated. Now, if a certain client with the ID PID has disconnected, then we get a close message. Okay, if we get a close message, we look up, okay, which player has left the game, and then remove this player with the ID from the hash map players. Of course, we must detach the spatial from the scene. So, okay, players node detach child, and now it's the same. From the spatials, we get this ID, and then it is detached from the scene and does not appear anymore. And now comes the most interesting thing here. When we get a message every 50 milliseconds, we update the scene, and then we send our own location and rotation to the server. So we just make a new position rotation message, and we put there into this message the location and the rotation. So this is all, and this works as expected.